I will. Oh.
Okay.
I was just going to mention the coroutine thing in brief. Just go through like the highlights. So like a function, you know, you're in the main you're in the main bit of the program, you go to a function, you do the function, you come back.
Yeah.
So the idea of it, I mean, I just said normal functions that we know from like 1970 and 1980 have been generalized in different ways. And one of these ways, although this stuff is old, it's like 1968 and stuff, is that you go to a function, you do a bit of it, you come out of the function, and then later on when you jump to back to the function that you started from, it remembers everything from before. Which, if you kind of think about it flipped, if you're in the coroutine column there, it's like you're calling out to somewhere else in a way.
It's more like just saying, oh, okay, I can't get any further. You do what you were doing. Can you come back to me later?
And things that I didn't mention actually in that talk was that, like, you have a function, you expect to have a return type. So when you drop out the bottom of that, you expect to have a return type. But when you jump out in the middle, it's conceivable to have no return type or to have a different return type. So there's things called generators, like in Python and C#, I think, that took me a long time to like, they're simple, but it took me forever to really tweak onto. It's like you can have a generator that gives you just integers. So one just hands you one, you call it, it hands you one, it hands you two, it hands you three, it hands you four. Or it could be prime numbers, hands you 1 and 2 and 3 and 5 and 7 and 11 and 13, whatever. And like, where does this idea come from? Like, again, I know some about it, but not enough. But it's in all these languages.
Well, I mean, it's yeah. I mean, the only times I can think where it's actually really useful is when you have to have communication and the packet arrives and you read from the packet and you get to the end of the stream and but it's not the end of the packet and you're still waiting for more stuff. So rather than sit there holding up the entire program, you just bail out, let the program do some stuff, and hopefully when you come back later, more data and survive.
And you know,
and then you can continue doing
and you know everything that you knew before when you were dealing with the previous stuff.
So would this be implemented as like some sort of equivalent anonymous method, which in Delphi is implemented as an interface object internally, even though we don't look at it like that?
Wait a few minutes.
Oh, sorry, sorry.
So yeah, it's in all. It's like it's in C#, it's in Kotlin, it's in Java, and C++ have been going to enormous efforts for like 5 years to add it to their language. So I can't see us ever like having it properly in Delphi, right? Because we don't have nothing. That's never going to happen. 5 years of work for it to become a a fundamental part of Delphi. So it's just something that's interesting. I guess one thing. So starting up a new thread. This is a logarithmic scale, and that line at the bottom is the cost for starting up a new thread in machine cycles, or maybe just swapping to a new thread. Yeah, just swapping to a new thread. So a function call is like 10 cycles, and the change of threads is like 1,000 or 10,000 to 100,000 cycles, whatever, a lot.
Is this expanded?
Yeah.
I can probably do it easier. If you go back to full screen.
Yeah, sorry.
Also,
Thanks.
So simple register operations. That works. Oh. So those are orders of magnitude.
Oh, that's
Right.
only zooming in this room, isn't it? Scott, but
Yeah, so they can't see that zoomed in.
yeah, sorry guys. But yeah, I highlighted a few different things there about what the cost of. So the idea is when you start up a thread, it has to have some stack space, and it's like 2 to 5 megabytes or something or other, and a coroutine can have like 50K overhead or something or other. So you might fit 5,000 or 1,000 threads on your machine, or 5,000. But a million like coroutines shouldn't be a problem.
But look at how expensive the thread context switches. That's 10 to the 4 to 10 to the 6 times as much as a register. I didn't realize it was that expensive.
I mean, exceptions are also in the same category.
Well, actually, I would have thought the thread context would be, well, I suppose maybe not, but yeah, I mean, exceptions are known to be expensive, but I didn't know thread context switches were going to be, I thought they'd been optimized, heavily optimized, because they're so frequent.
And this is on a log scale as well, so
Log scale.
Yeah,
even bigger than what it looks.
that's 10, and then, so if you, actually, if you blow up, then you have a clearer, right?
Scott will do it.
Yeah, no, but he.
Oh, well, we should probably move on. We've got to be out of here at 8:30. So, I just mentioned in passing, I can give you the PDF, no problem. And this is some Java, I think it was, and some operations on. So the big long bar there is for operating system threads, and the little tiny bars at the bottom are. So Windows has fibers that I don't really. They're sort of similar somehow.
Yeah.
But coroutines are completely in user land. They're just your own program. They're not to do with the operating system at all. But anyway, so the idea is they're meant to be fast. And when I was giving this talk, I was kind of concentrating on the idea of, it was someone had a library for it in Turbo Pascal 7.
Similar since 1977.
I was concentrating on the idea because it's not threaded, it's not multi-threaded, it's single-threaded. You're just jumping around between executions. Like if you do user interface stuff from a different thread, you've got to synchronize those changes back into the main thread. Whereas with this, you can just go wherever you want, and wherever you are, you can do whatever you want to the user interface because you're in the main thread. Now, I don't know if that's really how they're normally used, because I guess you would probably start a second thread and then have all your coroutines, maybe like for networking or something in this other thread. But anyway, I'm still learning. This is a test. Can you zoom that one? Yeah. Oh, there we go. I'm going to drag it. There we go. This is a Python. A Python generator. So okay. So you start here like I = 0, and then you're going to loop, and then you get to here, I squared 0 squared is 0, and you return that out of the function. So you're out of the function right here where the yield is. And then when you come back to this function, then you drop down here to the +1 and back to the loop and down here. And now I is equal to 1, so I squared is 1. So you send that out of the function, and this is kind of weird, right? It's like, this is not how we think of functions.
Oh, that's true.
But if you...
So that actually returns multiple times over.
So this is like an infinite list, really. It represents an infinite list of squares.
Yeah.
It just you're going to call it every single time you call it, it'll give you another one. And that's, I guess, the simplest type of routine, I suppose.
Yeah, it's kind of obvious when you look at it now, you can see the benefit of reading.
Well, I'm sure, I could be wrong, but I'm pretty sure I've looked at exactly this code and completely did not get it for over a year, right? It's like it's not sinking in, and
I mean, that yield is kind of like a return, except it's not actually a return.
well, it is. I mean, sort of.
It's a return and then it continues.
Yeah, it's a return with special conditions.
So is that, so can we do that in Delphi? Basically that. Aha.
So I got to this point, and I think it was like January, and I kind of reached my I'd kind of reached my level of like what I understood, and then someone popped up with this on Twitter. I think I'm gonna have to. Yeah. Kind of worked last time. There we go. I think you can zoom out.
Got the Zoom working, okay?
Yeah, I think so. You can probably go back. So this is written in C. And so you've got normal variables up here, integer, stop, step. You declare an enumerated type and then a variable of that type. So this is just normal variables. This is a construct. So this is like a record, this struct.
Yeah.
Oh, did I? Okay, that's interesting. So this is just the constructor. It just you give it a couple of numbers and it sets up the variables. So this is where the work gets done. Resume, and it's got a. I mean, if you look at this bit, it kind of looks like normal code, but then you've got this bit, and you're like, hang on a second. So if we go to the next page. Oops. So looking at the little inside bit, you've got a loop, and so you start with the state being like beginning or whatever, then you immediately change it to we are looping, and then you return, right? Well, if that return wasn't there, this would look like normal code. You're like, just set a variable, we increase the variable, we go around the loop, and then we're done, right? There'd be nothing really here to think about. But this switch statement acts basically like a bunch of go-tos. And so depending on the enum, you're at the start, you jump to here, the beginning of the loop. You guys ever hear about Duff's device?
What?
Duff's device.
Yes.
I think I heard about it in like 20 years ago or something. It's a C switch statement that will like add up, like increment 137 times or something. Like if it runs through once, that's 8 times. But it's this twisted logic like this. And yeah, it's something I saw a million years ago and didn't mean anything to me then. So when you've changed the state here and jumped out of the function, then when you come back, you get to the switch statement, you come down to in loop, and then you jump into the middle of this loop and keep going.
Oh, yes. Oh, that is cool.
That's like,
Oh, that is neat. Can't do that in Delphi.
can't you?
Oh,
Because like I looked at this and then I was like, oh, that's weird. And then I was like, I mean, we have go-to in Delphi technically.
Okay, so with the go-to, yes, oh, you can.
Oh, you can.
What about the user go?
And it looks beautiful, I mean, in my opinion, in Delphi. We've got okay.
There.
So we've got a record.
Got the delta.
Pardon?
Is it a delta sign?
We can have Unicode.
Sorry?
We can use underscore as a variable name.
Yes, but that's a,
We can use Unicode.
okay,
Yeah.
lambda, sorry, yes, okay.
When the talk was being broadcast and it got to that point, Ian was like, now I have to kill you. I was like, this is one big stir from one end to the other. So we've got a enumerated type, which looks excellent in Delphi,
Yeah.
and then we've got our variables, and then we've got our, we're declaring that we have a function and a constructor. And then the constructor is simple because we just, assign all the things. Just bang, 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 bang. And all the everything is in here. And so when you come into the function, you've got this case statement and these go-tos. And is this me or is this the?
In fact, you can simplify that because you don't even need the alpha one.
That's you doing the zooming, it's not.
Zoom
right out.
Yeah, you can simplify that because you can drop the whole that's the alpha because
Hang on, what are we doing right?
what's that?
Don't.
They're labels. They're labels.
Such a go-to thing.
Oh, and you have to declare them. You have to declare them at the, oh yeah, just up a bit. In the function, we declare label.
Label.
Look, labels. I was having so much fun doing this. I was like blowing my own mind.
Yeah, you would. Jeepers, that is.
Is that how you do it? I've never done it, Joseph. Is that how you do it?
I haven't done one for like 20 years.
I mean, you can't do a go-to just anywhere. It has to be within that function.
Yeah.
So it's a little bit sanitized.
Yeah.
And
Well,
it's
as long as that function is from the outside, stable, you do what you like inside.
and yeah, it does the same thing. It's like you come in with I equal to 0 or whatever.
So what are you label? Alpha, beta, gamma?
Yeah.
With that?
Yeah, just Greek letters. I was being
You've heard we've got one of our own, right? Like some kind of a
Those are
alphabetical list of characters with an English.
come on the Roman alphabet, too newfangled, we've had it for what, 20 years? Yeah.
I was stirring and it works exactly the same way as the other one. And I guess a side benefit is that you can declare like each of the this is one of those structs initialized with these functions, but then you've got a different variable, which is one of these structs declared with different initialized whatever. And you can call them and they work independently. I should get a photo of the look that it's giving me.
So they work independently, so when you say for I equals, so you're gonna do those 5 times.
It just came out like basically the first one's counting
Yeah,
1,
yeah.
3, 5, 7, 9, and the other one's counting 2, 4, 6, 8, 10.
What is it? Are you only declaring the labels so you can do a forward declaration and jump to it? So the label
It's for the jump. But the weird thing is we're jumping into the middle of a loop. Right?
Yeah,
That's wild. That's crazy.
yeah, that we were told even back like 30 years ago, you
Like-
don't do, never. But what about
If there was some way to deport me, they'd deport me, but no one will take me. So
That's neat, I like that, I hadn't thought about that, because
Oh.
we just got so used to not doing it.
I'm keeping a very open mind here because you have some big deep creds right now, just because of the Greek characters. I'm giving you a lot of leeway here.
So
You should go to it, but I'm also like, you know, see what you're doing.
the final thing,
Makes sense.
I talked about some other stuff. I said, like, I'm into, like, I called those things. So like a function with a record around it, which keeps some data, like
Yeah,
I called it a fortified function. Right. Because, but then when I think about it, it's like, but then classes are data and functions. But then this is on the stack and that classes are on the
yeah,
heap.
they end up being a bit different, they do, yeah.
It's like, I don't know, I feel like maybe there's something there, I don't know, but
I mean, you could turn it into a class, but then you have to instantiate it every time, but you don't want to do that, you just want to say, here it is. With the, you know, just have it on the stack while you're using it, and then you drop it, and that makes sense.
so I had in my head the idea of Conway's Game of Life. And like maybe because of the user interface idea, but then I couldn't get started like creating Game of Life from scratch, and I went to ChatGPT eventually, and it may be like a VCL and an FMX version that needed some work, but you know, it was a good start. And so this, no, not this one. Original. Okay, so this is the original one, just running Game of Life like you normally think of it.
So then each box, is that one of those record instances, like an instance of a game of one of those fortified functions?
Well, this is just normal when you take the whole matrix and then, you know, go through the whole matrix and update. But like you're saying, what I wanted to try was to make, so not really a coroutine exactly, but I made an anonymous function for every single cell.
Yeah.
And when they were initialized, so I picked like top 1, 2, 3, 4 corners and told it, you know, where it would be looking, because obviously it's not looking outside, and then the top row and the and told them all where to look. And so when the anonymous function was initialized, everything's a constant already about where it's looking. It's easier to see in the code, but anyway, so this is how it runs normal Pascal basically. And this is the one where there's 2,500 like individual functions with the responsibility for 1 square each, just running one after the other. And if you look in task manager, one of them takes up 1.6 megabytes and the other one takes up 1.8 megabytes. So
Which one takes up more than one of the coroutines?
this one takes up slightly more.
Yeah, this is one of the coroutines.
Yeah.
Yeah.
But anyway, for what it's worth, oh, and the last thing that I just found out in the last couple of days is that Dave Abrams, who was big in creating the C++ boost libraries, and then in the C++ ecosystem until he got pissed off with it, and then created Swift, or helped create Swift for Apple, and now is creating another language called, they were going to call it Val, but there were issues, so they're calling it Hilo. It's meant to be a value-oriented programming language. And somehow, I don't know, but coroutines are like fundamentally in there to provide the same sort of safety as Rust lifetimes. Rust variable lifetimes.
We got about 5 minutes until 8:30.
I'm done.
That's still.